want me to check anything now?
All right. So here we go. Let's spend the rest of our time on the practice exam.
I picked D. Still said it was wrong.
So part one, part one's non-graphic calculator. So it'll be just like it was last time. Part one will be non-graphic calculator, then part two graphic calculator. All right. So how'd you all do this one? Looking for what?
The translations.
Okay. How about powers? Let's talk about that first. Notice right away this is fourth power, fifth power, fourth power, fifth power. So let's think about that. So looking at that shape, looks like a snake. Does that mean it's got an even power or odd power?
Odd.
Odd. We all good with that? Because only odd powers, like x cubed and x to the fifth, do the snake thing, huh? Only odd powers. So no way A, no way C. They have even powers. They can't be right. Right? Because even powers like x2, x4 do that. So it's odd. So it's either B, D, or E. Now how do we know which one? Oh, B and D look the same. Oh, did I change it?
You said it all.
Didn't I change it? This is the old one yet. I just realized this is wrong. All right, here. Hold on. I've got a new one. This is different as the options. The options changed. See how in your options aren't B and D the same?
No, it's the same.
It kind of, yeah. The 4 is in a different spot, but it's exactly the same.
Right.
Yeah.
But see how on this one B there's a minus there?
I see.
It's different. Yeah, I updated. It was a mistake. I made a mistake on the old one.
Got it.
So so anyway, so here's the right one. Sorry about that. That was almost the same question. Here's the correct one. Let's try it again. So anyway, even powers, no. So forget A, because it's a fourth power. Forget C, that's a fourth power. So they're out. So now it's either B or D or E, and this time I've got the right answers up there. B and D are not quite the same. I grabbed the last year's version, and that had a mistake. So anyway, B and D are different. So how do we know which one it is? Is it B or D, or could be none of the above? Always haunting us there in the background, huh? Is it B or D?
Well, it's not flipped.
Well, the difference is whether there's a minus in the front or not. Did everybody see that's the fundamental difference? Everything else is the same. Is there a minus in front of the main thing or not? Well, what does a minus in front of the main thing do to a graph? Flips it. Minuses in front of a graph. Now, is that an X flip or a Y flip? Y flip, right? Minus on the X would be a sideways flip. Minus in the front of the function is a vertical flip. Has this graph been flipped, or is he doing what they normally do? He's doing what they normally do. He has not been flipped. No flip, right? They normally go low to high, don't they? The normal one with no flip, like x cubed, goes up to the right. Maybe that's a better way to say it. Up to the right. All the graphs, all the ones I've given you, all of them, literally, logs, exponentials, the original 6, all of them go up to the right, unless they've been flipped or something. Right? So if you see a graph that's going up to the right, down to the left, then you just think that hasn't been flipped. That's doing the normal thing they do with no flipping. So there's no flipping here, which means there's no negative on X like that, or negative in the front. So no way B. He's got a negative in the front there. See that? So it's either D or it's none of the above. Just doing that to be mean. No. I'm doing that because I want to make sure you can check a point. That's all we got to do now is check a point, right? As long I would just check one point. And really, I would do that all the time anyway because it's so easy to accidentally do some flip thing wrong, you know. It's always good to check a point. Is it really D? Let's just check one point. What point? What would be easy? This center dot would be easy. What does that look like? Back 5? Let's do back 5 for X. I'm just trying to go to that center dot. See if I get the right center dot. What am I going to get? If D is really the right answer. X plus 5 to the 5th plus 4. Plug in negative 5. Negative 5 plus 5 to the 5th plus 4. That's 0 plus 4. That's 4. Negative 5 up 4. Yeah. Looks like negative 5 up 4. Let's do one more. How about if I went 1 to the right of that, like negative 4? If I went to negative 4, I should be up a little higher, shouldn't I? on the graph anyway. Let's see if that's right. If you put in -4, I'll do one more here. Put in -4, you're going to get -4 plus 5 to the 5th plus 4. And that is 1 to the 5th plus 4. That's 5. Yep, a little higher. -4 up 5. Looking good. That's it. D. See how he's working perfectly? We good with that? Everybody see that? So you won't have your graphing calculator, but you'll have a handheld calculator. You can check those numbers, you know. Questions on that one? So you see how I eliminated? I said no way to the even powers. And then I said no way to the negative in the front because that would flip it. This one has not been flipped. It's going up to the right like they normally do. So it was all down to D, and I plugged in 2 points. And it looks good. All right. Let's try number 2. So, what do you think? Yeah, wouldn't be bad. Right there, that point right there you're talking about? That's a good point. So that's got to be the point, what is that, over 0 up 2? Over 0 up 2 better be on the real graph, huh? So you could just make an exponent table, plug in 0 to all of them, and you should get positive 2. That could be a lot of plugging in, but you could do that. Could we just eliminate any, like, right off the bat for any other reason so we don't have to plug into everybody? But, I don't know if you have time to do all that. Why can we eliminate A?
-2.
What's wrong with the -2? Yeah, that would be a vertical shift. That'd be an up-down movement shift. What's the basic graph here? It's 1 over x. What's the 1 over x graph? It's like this, and the asymptotes are right down the middle, right like that. That's the normal graph. Then there's been shifts, huh? So if you put a -2 out here, that would move the whole thing, the center crosshairs, down 2, 1, 2, right to here, wouldn't it? That's not right. His horizontal is still on the line. So it's not that -2, no. It's not this +2 either, no. It's either B or C or E, right? Everybody good with that? You can't have a -2 out there. So try B and C. Look at B. See that minus in the front there? What's that going to do? That's a vertical flip. That might as well be a minus in front of the whole fraction. That's the same thing as -2 over x minus 1, right? Minus in the front, minus in the top, same thing. So what? Will that mean a vertical flip? Has this thing been flipped vertically? No. Yes.
Yeah.
So yes.
Say, what do you mean?
No. Yes. Yes, it has. It's exactly. Right? This part's not here. It's been moved up there. This part's not upper right. It's lower right. See, they turned it vertically. It's got to be B. Anyway, let me plug in some points now. I'm thinking it's got to be B. Let's plug in some points and see. Let's see. See how this one's been flipped? See, he doesn't go up to the right, does he? He's down in the right. Up in the left. He's been vertically flipped. The graph's the normal graph is upright and lower left. Like I said, for all of them, normal is upper right. So this one is lower right. It's been flipped vertically. That's what that negative on B is going to do. Let's check it, though. So I'm thinking B. Plug in the 0. -2 over x minus 1. So -2 over 0 minus 1. So -2 over -1. Positive 2. Over 0 up 2. Yeah, beautiful. Over 0 up 2. If you plugged into C, it wouldn't work. I'll show you. If you plug into C, 0, you're going to get y equals 2 over x minus 1. 2 over 0 minus 1, 2 over -1, -2, 0, -2. No. B it is. Good? We all good? You guys becoming lean, mean graphing machines? Sorta? All right, that one. Look at all the equations are exponential. Hitler's climbed into power, X has climbed into power, right? So they're all exponential. Now, what do we know about an exponent? The general thing I gave you is b to the x times c plus a. Remember, I gave you the form. This would be good to have your 3x5 card. That's the form of any exponential. And what is the a? What is the number out there added or subtracted? Horizontal asymptote. Remember that? Do you remember that on an exponential graph? That the number added or subtracted off to the right is the horizontal asymptote. So what's the horizontal asymptote looking at the graph on this one? 2. It's up there at 2, isn't it? So it's got to have a +2 out there. Not a plus 3. Plus 2. So it's either C or D or E. Now, am I going too fast? Is that good? C or D or E. What do you think from there? What's that? Plug and check. You can plug in some points. How about flips and stuff? Now, how's it been flipped? Does it go up to the right? Because normally, all the graphs if they start out with no flips, up to the right. This one is not going up to the right. He's going down to the right, isn't he? Right? See him going down to the right? And up to the left? So he's been flipped somehow. How's he been flipped? Has he been flipped sideways or vertically or both? What's the normal look like? When I have the normal goes like that, right? This is normal. So and this one's going like that. So how's it been flipped? Sideways, yeah, horizontally. Everybody see that? They flipped it like this, sideways, didn't they? They grabbed this and flipped it sideways, didn't they? So so they flipped, so this is a sideways flip. It's not vertical, it's not going down, is it? It's not like down here. Right? It's not been flipped vertically, it's been flipped sideways. Everybody see that? So, okay, it's been flipped sideways. What makes something flip sideways? Negative on the x rather than the front. So which one has negative on the x? It's got to be. No way is it D, because D has negative in the front. That would be a vertical flip. That would go down. So it's either C or maybe E. Right? So we got to check C. It's probably C. So let's try that. What are you going to plug in? I don't know. 0 might be good. Whatever you want. The 0 is pretty obvious. Right here, 0, 3. See that point? 0, 3. Let's check that out. 0. 5 to the minus x plus 2. 5 to the minus 0 plus 2. Minus 0 is just 0. What's 5 to the 0? What's anything to the 0? 1 plus 2, 3. Yep, beautiful. 0, 3. It works perfect. 0, 3 it is. So C it is. Is that good? How we doing? Are we good? Questions? Okay. What do you think about that one? What do you think? Do you know the basic form? So what you want to have in your 3x5 card, everybody seen the game plan for these? You want to have in your 3x5 card all the basics. Like I gave you the basic exponential form. Because see the pattern? It's very obvious. So there'll be one exponential graph, there'll be one log graph, there'll be one like other kind of graph, you know. So this is log. Obviously they're all log. So you want to have the basic log. And what did I write out for you? Log base b, and I put x plus v, meaning negative v, opposite, right next to x is opposite. Negative v is the vertical asymptote. Remember that? So you want to have that in your 3x5 card. You want to have that, and this one I put here for the horizontal, for the exponential. You want to have the basic log graph, the basic horizontal graph and equation on your 3x5 card. And so then when you see this, you want to go, okay, let's match it up. What do we think? I get the v plus v minus v. What's the vertical asymptote on this graph? What's the vertical asymptote? It's right here. It's at 0. The vertical is at 0. So that means the number in the parentheses next to x is 0. Everybody seeing that? So no way B, no way C. That's got a 2 in the parenthesis. They both have a 2 or negative 2 or whatever. Some number other than 0 in the parenthesis with x. No way B, no way C. Everybody see that? See, B and C, they would have a vertical. B would have a vertical asymptote at positive 2. C would have a vertical asymptote at negative 2. Or I don't know, vice versa. I'm afraid it's opposite sign. But anyway, some kind of 2. Not at 0. You with me? It's either going to be A or D. Why? Because on A, notice the no parentheses. That's a big deal. That really matters, doesn't it? That makes a big difference. A doesn't have parentheses, which really means only the x is plugged into the log, and the minus 2 is outside of the toaster, outside of the log function. You getting that idea? Whereas on B and C, the 2 is in the parentheses, which means he's the vertical, and that's not right. Our vertical is 0. There's not supposed to be anything in the parentheses with x, is there? Just 0. So therefore, it's not B and C. It's either A or D or E. So how do we know which one, A or D? Talk to me about flipping. Has this graph been flipped, or does he do the normal thing? What do graphs normally do? What do all of them normally do?
Would the negative 2 be like...
Go up to the right. Does this one go up as you go to the right? If you're riding the roller coaster, I'm riding the roller coaster here. Woo, I'm standing up on the roller coaster. And I'm going to the right. Am I going up? Yes, indeed. Which means no flips. Right? He's doing the normal thing. He's going up to the right. That's the normal thing. No flips. Chris, a question?
Would the negative 2 be like a shift or an asymptote? It would be an asymptote or...
It's not an asymptote, but it's a vertical shift down 2. Yeah. So no flips. So what does that mean? No flips. No negative in the front. Bye-bye, D. He has a negative in the front of the log. That would be a vertical. That would make the whole log thing turn upside down, and the thing would go down to the right instead of up, huh?
And it will be up there, but it's positive.
Oh, sure. I'm a little hesitant on that because this log, notice, yeah, I know, I'm a little hesitant on it because this log does go up. It'll go up forever and down forever. So it'll eventually reach all heights and all depths. So I want to be a little careful about putting too much stock in that kind of thing. Right, but it can't be this because that would mean it would head down instead of up. Everybody with me on that? So it's not D. So you see how I always get down to just like one option? By looking at flips or lack of flips and looking at either the horizontal or vertical asymptote. Is that making sense on reasoning that out? On that? So now it's either A or E. It's probably A. You know, if you're running out of time, just grab A and come back to it at the end of the test if you have time. You might not have time to do all this plugging in. That's what I would do if I was under pressure over time. I would look, it's probably A, bubble A, make a note on your test, come back if you have time at the end to check it out, but it's probably A. So let's be sure. What do you want to plug in to be sure? Don't want to plug in 0, it doesn't exist, but how about like 1? Oh, this looks like over 1 down 2 to me. Looks like the dot over 1 down 2. Put in 1. Is A right? Log x. Remember that minus 2 is outside of the plug-in. So log 1 minus 2. What's log 1? Button on your calculator is 0. Over 1 down 2. Beautiful. There it is. It's perfect. Is that good?
This is the part without a calculator.
Yeah, this is all the... No graphic calculator, this part, right? Is that good? Anything I can say to help? Those little tests making sense? About the flips or lack of flips, Rudy? Log, what's that? I plugged in 1. The x was 1. So I plugged in 1 for x. Right, you can hit the button on your calculator. Log of 1 is 0. Log of 1 is 0. Well, that's right. Because the reason is because log says power needed on a 10. There's an invisible 10 there. What power does a 10 need to be? 1, 0. Just hit the button. So there we go. All right. Okay, so number 5. 1/3 to the power of 5x plus 6 is 9 to the power x minus 2. So how do we solve these, like, power things? Make the bases the same. Yeah, good job. You remember that? We have to make the bases the same. So, make bases the same. So how do we make the bases the same? Well, we can make them both 3, can't we? What do you do with 1/3 to make it 3? -1. Remember, negative powers flip things? And the other side, 3 to the second. Everybody see what I just did there? Do you remember negative powers 3 to the -1 is the same as 1/3? Remember that from algebra? Negative powers flip things. So 3 to the -1 is 1/3. And 3 to the second, that's 9, huh? So I made them both 3. Okay. Now, this power is going to go boom, boom, and this power is going to go boom, boom. And you can get rid of the 3's now. Once the base is the same, you set the powers equal. So -1. Well, I'll just distribute it here. What's that? -5x minus 6 is 2x minus 4. Am I going too quick? Everybody see what happened there? Just distributed that. -1 through and the 2 through. Now how do we solve for x? X is saying I want to be alone. Just get rid of one of them, huh? It doesn't matter. Like go minus 2x or add 5x, whatever. Minus 7x minus 6 is -4. Add 6 to both sides. Minus 7x is 2 divided by -7. Minus 2 sevenths. Is it not there? Is it none of the above? It's disturbing, isn't it? There we go. Oh, we canceled them out because remember how we did that earlier? If I said 3 to some power is equaling 3 to some other power, those powers have to be equal, or 3 to one of them wouldn't equal 3 to the other. Remember the logic there? Right? If I say, hey guys, I'm thinking of some power. When I go 3 to that power, I get the same thing as if I do 3 to this other power. Well, that other power has to be the same as the original power, or 3 to one of them wouldn't equal 3 to the other if they were different, right? If this was 1 and this was 2, 3 to the 1 wouldn't equal 3 to the 2. You with me logically? Is that everybody making sense out of that? Why I was able to eliminate those bases? That makes sense? If 3 to some power is equal to 3 to some power, right? Then those powers have to be equal, don't they? Good? Okay. So 4 to the x minus 1 is 32 to the 3x. So try the same thing there, huh? Make the bases the same. Bases the same. Can you make 32 4 to something?
No, it's 2.
Yeah, it won't work, huh? If you try, if you say, well, I'll just do it 4. If you multiply a bunch of 4s, it'll be too big. You can't. So you got to make them both out of 2. Yeah, make them both out of 2. Because 4 is 2 to some power and 32 is 2 to some power. Just use your calculator to make them both out of 2. Yeah.
When I did this question, I kind of went the opposite way. I made the bases both bigger. I still made them the same. It's just I made them like something a little bit, but they ended up matching. Is that okay as well?
Sure. Never thought about that. Make them both like 64 or something?
It's like 1,000 something. It's a really big number.
And then what did you do with the 4 then for the 1,000 whatever?
It was like 4 to the 5th power equals like 32 to the 2nd power.
4 to the 5th is 32 to the 2nd. True. That's exactly right. Yeah, actually, that is true. So what did you do from there?
I just did the same thing once I got the equations the same. Or at least once I got the bases the same. I just did the math.
Okay. Great. Yeah. All right. So how are we doing? So this will be 4 is 2 to the 2nd. And 32 is 2 to the 5th. Is that good there? So I've made the two bases the same. And so again, the logic is once the bases are the same, if 2 to something is equaling 2 to something else, those powers have to be the same, because if they were different, then 2 to one of them wouldn't equal 2 to the other if the powers were different, right? So then I know this power must equal that power, because 2 to one of them is equaling 2 to the other, right? So the powers must be equal. So that means distribute this 2x minus 2 must equal 15x, huh? And then subtract 2x from both sides. Negative 2 is 13x. Last step. Divided by 13, negative 2/13. Ah, there we go. There's an answer we can find. Good on that. Questions I can answer? All right, I'll make you notice that.
There was another video that said number 7.
Oh, yeah, you found that?
Yeah.
Good. That's right, I posted that. I forgot about that. Yeah, I posted a separate video that showed 7 and 9.
There was another video.
That's right. Good. You all found that? Yeah, the 7 and 9, I changed them from the practice exam when I taught the course last time. So 7 and 9 are new practice exam questions. What does that mean to the wise student? Mr. Heron spent time last year, or whenever I taught pre-practice last time, to go back in and change and put a brand spanking new number 7 and number 9 on the practice exam. What does that mean about number 7 and number 9? They must be important, yeah. And I don't even remember exactly what's on the test. I made it up 6 months ago. But I know how me or anybody else thinks. If I'm spending all that effort to make a new number 7 and a new number 9, it must be for a purpose, right? There must be something like, now, I mean, there's something like all these. But specifically, I must have felt like I didn't prepare people well in the past by giving them something more like number 7 and number 9. So make sure you know number 7 and number 9, right? I'm being pretty obvious about it, right? So number 7, number 9, if I updated them, they must be important. So look at number 7 and number 9. Let's solve it. How do we do it? What'd you get out of that YouTuber? What'd you figure out? How are we going to tell which of those graphs are right? No graph. This is the no graphing calculator part. How could we look at that thing without a graphing calculator and figure out which graph is right? It's about asymptotes. It's all about horizontal, vertical asymptotes. Yeah. So how about we start with vertical? We'll start with vertical. How do we find the vertical asymptotes from an equation? Denominator. Denominator 0, right? So grab that denominator equal to 0, and that'll tell us the vertical asymptotes. Good? X squared minus 3 equals 0. So set the denominator 0, and that's where you always find your vertical asymptotes. So how do we solve that for x? Can you solve that for x real quick? Don't forget when you put a roof on the house. If you only say square root of 3, you're in trouble. When you put a roof on the house, you got to go up and down. Really, 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 really important. All those little details. You've got to work and work and work until you don't forget those kind of things, because it'll, like on this very problem, it'll really mess you up. So it's plus or minus root 3. Root 3 calculator, 1.7 something, huh? So that means plus or minus about 1.7. Let's start with 3. There's got to be two vertical asymptotes, doesn't there? Yeah. One at positive 1.7 and one at negative 1.7. Two vertical asymptotes. So which of these graphs have two vertical asymptotes? C and D. They're not showing them, but you can see it's right here and right here. See how the graph is conforming to an invisible vertical asymptote? They're not showing them, but you can tell what the graph is doing. There must be verticals on the left and the right, on C and D. Bye-bye A, bye-bye B. A only has one vertical. I don't see any verticals on B. See, if you only had the positive here and you forgot the plus or minus, you would think the answer is A, because he's only got the positive on that. So everybody see that's really important when you put a roof on the house, up and down the ladder. Okay, so now is it C or is it D? Horizontal. Now let's talk about horizontal. This is all about asymptotes. This problem is all about asymptotes. So how can we, do you remember how to find horizontal asymptotes? Now vertical is denominator 0. How do we find horizontal? Powers. So horizontal asymptote. It's the biggest or largest on the top and the bottom, right? Because remember, horizontal asymptotes are about what happens as you go way off to the right or the left. You go off to 10,000 and 10 million, way off to the right. So if you're plugging in x's that are super, super big, all that's going to matter is the most powerful term in the top and the most powerful term in the bottom. So we get x squared over x squared, which is 1. Y is positive, regular 1. Which one has a horizontal? Remember when the numerator and the denominator power are equal? It's y equals a over b. That's the coefficients, 1 over 1. Remember I gave you that whole table? So look back to that whole table I gave you for horizontal. I said numerator power greater than denominator, denominator greater, and what that all means. You know, we went through all that. So if they're equal, it means y equals a over b, where a and b are the coefficients in front, 1 over 1, or just 1. So y is positive 1 is the horizontal asymptote, which is D. He has a positive 1. The other one, C's is negative 1, isn't it? C's wrong. D is our right answer. No E. No, none of the above. Isn't that nice?
There's a negative x squared on the bottom. Yeah.
Everybody good on that one? So it's all about just finding the horizontal and vertical asymptotes. D is the only one that has the right horizontal and vertical asymptotes. All right, on where we go. Hey, that 6, is that a base?
Yes.
Yes, remember the program doesn't put them very far. I don't want you to be surprised on that on Thursday. So try that one. Can you solve for x there? Solve for x. So we're trying to solve for x. It's like there's an invisible wall here, and x is saying, I want to be alone. So what do? How are we going to get rid of that log? Power that matches the base, huh? Is that good? Just like we were doing a few minutes ago? Does that make sense? So the power cancels the log like that. And we get x squared minus 5x. 6 to the 1 is just 6. Is that good to there? So that's how we get rid of logs, right? Whenever you're trying to solve some kind of log thing, you just do the power that matches the base. It goes the same. Okay? Now, can we finish solving for x?
Is it 1 to the 6th, or is it?
So it's 6 to the first power?
And you subtract 6.
So I put the 6. The 6 is the... Makes sense? So now, you just bring this over, subtract it. X squared minus 5x minus 6 is 0. Like that. And then we factor. Remember how we always handle x squared equations? Bring that over and factor. Now can you factor that one? Remember they have to multiply to be minus 6 and add to be minus 5. What two numbers multiply to be 6, negative 6, and add to be negative 5? Could I do negative 2, negative 3? That makes negative 5 in the middle, but what's the problem with it? What does it not do? Yeah, two negatives would make positive, would multiply to be positive 6, so that's not right, huh? So it's not 2 and 3. It has to be 6 and 1. And the sign in the middle goes on the bigger, doesn't it? Always. So minus 6 plus 1 makes minus 5 in the middle, and that multiplies to be negative 6. So that's right. And then the answers, though, end up being the opposite, don't they? because you set each one to 0. Remember the logic? If two things are timesing to equal 0, either one could be 0 to make them times and be 0. So you set each one to 0, and then it's just jump it over. It's positive 6, it's negative 1. So the answers are 6 and negative 1. So A. Except log questions have to be checked. You know what I mean? Do you remember that from logs? You have to check them, meaning if I put in the negative 1 and it makes the inside of the log negative, or 0, then I got to throw it out, and the answer is going to be C, just the 6. So you got to watch out. Wouldn't it be a bummer to do all that good work on a log question and then forget to check it right at the end and get it wrong? So we got to check it. So how do we check it? Inside of logs, not 0. Remember how they can't be 0 and they can't be negative. Not 0, not negative. So if I take that minus 1 and I put it back in to this inside, we'd have log base 6, negative 1 squared minus 5 times negative 1. What's that going to be? 1 plus 5, 6. The inside is 6. It's okay. They're both good. The answer is A. Did that make sense? I didn't actually work out the whole thing, did I? You just have to make sure the inside is not 0, not negative. It's positive 6. When I plugged in the negative 1, negative 1 squared was positive, and negative was positive. It was all good. Is that making sense? So logs, the inside cannot be 0 or negative. Is this like too much information? Are you feeling like it's just a ton? There's a lot on this test, isn't there? There's a lot of information to keep straight. You can just put it all on your 3x5 card. No, I'm kidding. There's not enough room for that, is there?
You do write really small.
Is any of your test curve?
What's that?
Don't tell me there's not enough room.
Is any of your test curve?
I give the plus 5. Let's try. Let's try that. Now, number 9, this is another new one. So heads up, for sure on the exam. I mean, I bet, I guess. I don't exactly remember. I made the exam probably 6 months ago or something. But, it's a new one to this process. Number 9 is new. I updated it. So, right, if you looked at the old YouTube, you might want to know, how do we know? If you watched the old YouTube, you'll saw there was a different number 9 before. 7 and 9 were totally different problems. So, let's take a look. That's a hard one. Anybody get this one? No, how? I mean, I might have got it eventually, but figure it out. Feel like you really understand it. What do we do?
Asymptotes.
Asymptotes.
And where it touches or passes.
Good. Let's start with asymptotes. So, what asymptotes do we see? Yeah, we got a couple asymptotes. It looks like right here. That's what negative, because this is 0 here, huh? So negative 1, and 4, right? 4. So negative 1 and positive 4. Got a couple of vertical asymptotes. So what? What does that mean about the equation or the formula?
You can eliminate C.
Yeah, why?
Negative 2, negative 6.
So what you're saying is denominator.
Correct.
And you're totally right. So this stuff has to go in the denominator, and it has to be opposite. So x plus 1 and x minus 4 must be, because verticals are in the denom, aren't they? And they make the thing 0 in the denominator. So if you put in negative 1, that part would be 0. Positive 4, that part would be 0. Correct. It's got to have an x plus 1 and an x minus 4 in the denominator. C is out. The other ones have that. So far, so good? So that only eliminated C. The vertical asymptote observation only eliminated C. So what's the next observation we can make? You could try horizontal asymptote, but I don't think it's very clear on this graph. And it wouldn't be easy. Let's, instead of horizontal.
What is the power on the x minus 4? What is that?
Yeah, the power on the x minus 4, it's hard to tell because, it's. I'm not going to mess with that. Not with a vertical, not much. Yeah. The other thing we look at is where the thing hits 0, meaning right here at 2 and right here at 6. Those are zeros, aren't they? The graph actually hits a height of 0 at 2 and 6. What does that mean about the function? Where do we see that 2 and 6? In the top, huh? Opposite again. X minus 2, x minus 6 must be in the top. Because the top are the zeros. Remember that? Remember how the top has zeros and the denominator has the verticals? Has the vertical asymptotes. So the top has the zeros and the denominator has the vertical asymptotes. Remember that? Remember that's always how that works? Okay, great. So what? They looks like they all have x minus 2, x minus 6 in the top. That really didn't get as far, right? A, B, and D all have x minus 2, x minus 6, x minus 2, x minus 6, x minus 2, x minus 6. But what do they have different? The powers. See how this has a 2 power? So does that. But this has a 1 and the 2's on the other guy. So what do we know about the power? So this is making us really be specific about the things we know about the bounce pass-through rules. Remember those? This one's a bouncer. He bounces, whereas this one passes through, huh? What does that mean? When you bounce, what does that mean about your power? Even power. And when you pass through, odd power. So there's got to be an even power on the 2. Well, that's good. A's good. B's good. D's out. D has an odd power on the 2 and even on the 6. That's vice versa. So with all this analysis, now we're down to A and B. We still have to, there's no E, but it's either A or B. This is where it's time to look really closely at A and B and say, they're very similar. I mean, they're very, very similar. What's the difference between A and B? There's one small difference, that 2 in the front. And the only way we're going to figure that out is plug in a point. Now we have to plug in a point. We're all the way down to this. We've done all we can with vertical asymptotes and zeros and bouncing and passing through. Now it's vertical asymptote time. So let's do it. So I'm going to take an x, y, it's plug in a point time. So what am I going to plug in? What's an obvious, easy point to plug in? 0. Looks like right here, this is 0. It looks like negative 1.5 or something. Doesn't it? 0 down 1.5 to me. So if I plug in 0, I should get down 1.5. Right? You agree? To the real answer. So let me just start with A. If I plug in 0 to A, if I take A, I put in 0, 0, 0, 0, what am I going to get? Negative 2 squared times negative 6 over 1 times negative 4 squared. What's that? 4 times negative 6 over 1 times 16. It's at negative 24 over 16. Negative 1.5. Oh, yeah. Beautiful. Hey, it is. That worked perfectly. Over 0. Down 1 point. If you plug into B, you'll get a different number. You get down 3 is what will happen. Because that 2 will double the 1.5 to be 3. That's wrong. So A it is. Yeah?
What if you are on a time crunch and you didn't have time to plug it in? What would you do?
Yeah, I think this one you have to plug in. Flip a coin. Yeah, I can't see any other way than plugging in on that one. Yeah. No, I think you can get it done. We good? No. All right. Horizontal asymptote. All right. So can you find the horizontal asymptote of number 10 there? We got 35 minutes. I'm going to have to pick up the pace here a little bit. All right, so how do we find horizontal asymptote? Highest power, highest power. Remember that? Y is x squared over minus x to the fourth. The numerator power is 2. The denominator power is 4. Remember the rule, if the denominator is bigger, which ours is, it's y equals 0, which is none of the above. It's disturbing, isn't it? None of the above. Y equals 0. Because the bottom wins the tug-of-war and pulls the graph down, doesn't it? The bottom is more powerful. So as you go way off to the right or way off to the left, plug in 1,000, a million, a billion. The bottom is going to be so much bigger than the top, it's going to pull the graph down to 0 height. It'll end up being like 1 over a million. And 1/millionth is basically 0. If you have 1/millionth of the pi, you basically have no pi. Right? The bottom wins the tug of war. Denominator's bigger. Number 11. Look at the numerator power, denominator power. 6x squared over 4x squared. When they're equal, when numerator equals denominator, in that case, you do y equals a over b. 6 over 4. So it's just, they tie, so the x squareds cancel. It's just 6 over 4, 3 halves. There it is. Is that good? Horizontal one's easy? It's just numerator power, denominator power. Have that little table that I gave you. You know, that'd be definitely important to put on your 3x5 card, right? Remember those steps I wrote out? If denominator's bigger, it's y equals 0. If they're equal, it's y equals a over b. Right? Remember those? And there was another rule as well. So look back to those rules I wrote out for you. In fact, I could just write it. Here, let me do that. One more time. So for horizontal asymptotes, here it is. If the denominator is bigger, it's y equals 0. If they're equal, it's y equals a over b. If the numerator is bigger than the denominator by 1, then it's an oblique asymptote, meaning diagonal. Right? Remember that? Diagonal. And you have to long divide the denominator into the numerator. Remember that? Into the numerator, and the answer is right up there. And then step 4, if the numerator is bigger than the denominator by 2 or more, it's no horizontal, no oblique asymptote. So there's the steps for finding horizontal or oblique.
Does it mean that the only time that we will have oblique is number 3?
Yeah, only time you're going to have oblique is number 3. Yep. You can't have both horizontal and oblique. The asymptote either goes off flat or goes off diagonal. Yeah. Or neither. Remember that? So that's what you need on your 3x5 card for the horizontal asymptote questions. All right, so how do you find the vertical? Yeah, factor if you can. We can't factor this. So then denominator equal to 0. That's how we find vertical, right? So x squared plus 49x equals 0. Good on that. So for verticals, it's denom equals 0. It's just about like domain, huh? Denominator 0. So how do we solve that now? X squared plus 49x equals 0? What do we do to solve that? Factor out the x. Take out the x. And then each part gets its own 0. Because if two things are timesing to be 0, either part could be 0. So x is 0. Jump the 49 over. X is minus 49. 0 and minus 49, on that, yeah.
Why would you put
As opposed to what? To what's that?
just say just like trying to factor it, or is that you can't factor it?
That is factoring. What do you mean? What else would you try to do? That is what I just did is factoring.
We do that because we don't have a C, right?
Have a C.
Like then.
Oh, right. That's why I didn't do the 2 parenthesis factoring.
Yes,
Right.
yes, that's what we did, because you didn't do the 2 parentheses factoring. Is it because there is no third?
Oh, yeah. There was no third part. Yeah, if there was x squared, say plus 49x plus 14 or something, then I would do the 2 parentheses. Is that what you mean? Yeah. That's all called factoring. It's just when there's 2 things, you take out the GCF. You take out what's in common. When there's 3 terms, you do the 2 parenthesis factoring with the x's in the front. Yeah, that's good. Good question. Everybody aware of that? So if you just have two terms, you take out what's in common. If you have three terms, you do the two parentheses on that to factor that. Everybody good with those different kinds of factoring? Come see me or Tim. Get the help you need. We'll be glad to do some more factoring. Going real thorough and real slow. Number 13, rectangular. Oh yeah, we did the river one before, right? Now I promised that there would be one of those three on the exam. So either the river one, or we have the box with the sides and the top and the bottom, and it wanted the volume to hold.
What section was that?
Yeah, what section was that? Was it 5-4?
I was pressed for time as you told him. I couldn't find the section to look at. 4.3? Thank you.
Let me double check. Yep, you're right on the money. That's 4.3. Yep. Section 4.3. What numbers were there? There was like three. Anybody have the numbers in front? Oh man, you're the man, Shanu. 17, 18, 19. Oh, I can't write this. 17, 18, 19. One on the test. One of those is on the test. So remember, there was the river, there was the soda can with the top and the bottom, right? And there was the box, the three-dimensional box with the four sides and the top and the bottom. So one of those three will be on the real exam. I don't even know which one because I don't remember. I made it up so long ago. But one of those three is on every one of my exams. It varies from exam to exam. So I'm right. So let's try the river one. But make sure you look back to 4.3. And you can do 17, 18, and 19. Because they're all, one of those three will be on there. All right. So the river one real quick. Got a river. Got three sides. And it says the fencing for the sides parallel to the river is $4. This is the side parallel. The other two sides, $7. So this side is 7, 7. They're saying let x be the length of the sides perpendicular. So this is x. These two sides are perpendicular to the river. They hit the river at 90 degrees. And the other side I'll just call y. So everybody good? So this distance is x. This is x. This is y. The cost is 7x, 7x, 4y. And then the four posts, they're $20 each. 1, 2, 3, 4 posts. So what's the total cost function? 4 times 20, now there's $80 for the four posts, plus 7x, 7x, and 4y. So the cost function is 80 plus 14x plus 4y. Is that good to there? Now there's the cost function. It's almost done, except we can't have y. Remember, we always have to plug in all three of these problems, 17, 18, and 19, you have to plug in for the y using a second equation. What's my second equation on this one? What other fact have I not used? 2,000 square feet. That's the area. How do you find the area inside of a rectangle? Length times width, right? One side times the other. So the area, 2,000, is one side times, so x times y, huh? X times y is 2,000. Is that good for the other equation? Area, one side times other. So what are we going to do with that? I'm going to solve for y and plug in. So divide by x. So y is 2,000 over x. Put it in right there. So what do we get? The cost function is 80 plus 14x plus 4, and then plug in 2,000 over x. Because that's what y is. Y is 2,000 over x. So what is that? 80 plus 14x. And what, 4 over 1, so that makes 8,000 over x. Which one is that? Oh! All right. There we go. Is that good? Is that making sense? Remember that. Make sure you look back to the soda can and the box, 17, 18, and 19. Better. Economists use what's called the Leffer curve. somebody named Leffer came up with, to predict the government revenue for tax rates from 0 to 100%. Economists agree that the endpoints of the curve generate zero revenue, but disagree on the tax rate that produces the maximum revenue. Yeah, we know they disagree. Suppose an economist produces this rational thing here, where R is revenue in millions at a tax rate of X%. Use a graph calculator to graph the function. What tax rate produces maximum revenue? What is the maximum revenue? All right, so basically it's typing into your calculator. This is a Y1 equals 10x times 100 minus x divided by 25 plus x. Put that into your calculator and hit the graph button is what it is. So just put that in, hit the graph button, and find the answer on your calculator. It's easier said than done. You want to try that? How are we doing on time? 20 minutes? I'm not going to make it. All right, I'm just going to have to say, yeah, but I want, this is not simple. I'm saying it's simple, but it's not simple. If you type that in, you can. First off, notice I put parentheses around the denominator. Remember, whenever you type into your graphing calculator, you always have to put parentheses around the numerator and denominator when you type them in. So really, I should have put parentheses around that and that. So put parentheses around the numerator and the denominator when you type it in. That's one thing that really messes people up. And then when you graph it, you're going to have to get your window right. How do you get your window? It's a lot of trouble. People have a lot of trouble on this. I wish I had time to go through it all again. We only got 20 minutes. I got 10 problems left. Yeah?
A quick thing, I don't know, the two in the circular center help is good. If you don't want to do the table, then you struggle.
Do you have another method?
You can put it, you can get it to list auto, to list everything on the table. Remember how we would plug points in, like instead of searching for the max?
Yeah.
You can just get it to list all in the table, and then it'll find, if you look at the value, right, when it starts to drop,
Yeah.
you know that's your,
Your max?
Yeah, the max.
List all, but how do you know if it's not like between, like if you're looking at a table and it goes 1, 2, 3, 4, 5, and it goes up at 4 and then down?
Watch your values because it'll say, it says something right here, use your graphing calculator to get the rate. Well, you just, once it starts to...
So, Matthew, I'm not sure you understand my question. So I hear what you're saying. Make sure you hear what I'm saying. So I'm saying, like this, say this is 100. Say this goes to 120. This goes to 130. And then this drops back to 120. So you're saying it starts to drop right here, right?
Yeah.
Okay, so you're saying, well, the max is at 3.
That's what they told me to do.
How do you know it's not 2.9?
Well, I'm just, if you go on that one by looking at the values that they had, they said process of elimination, looking at it. Then I have to
Wow,
look at
that
it.
sounds a little shaky to me. I mean, I'm always willing for other methods, but...
I'll show you because that's what they showed me to do.
Yeah,
they... I was having trouble setting up the table for some reason on my calculator. And he said just go to auto.
I better move on. I don't, that sounds shaky to me.
Okay.
It sounds like they maybe got lucky on a guess or something. Okay. Yeah, so just because, you can get sort of close, but how do you know 2.9, 2.8, 2.7? How do you know more specific than that? And they're asking for more specifics on these percentages. So anyway, so basically you just got to put it in your calculator, graph it. This is a graph, and find the max value. The problem with the graph is people hit the graph button, they see nothing on their screen. What do you do when you see nothing? You've got to hit second table, right? And then set the Y max to be the right Y max. The other problem on this one is the X's are all decimals, right? 28.8, that's 0.288, isn't it? Decimal. So the X min should be 0. The X max should be 1. Everything happens between 0 and 1 on X. That's what really messes a lot of people up. They don't notice that the X values are percentages, which are decimals between 0 and 1, really. So that's the other thing. Make sure your X goes 0 to 1. Use second table to find your Y max. Get a good graph. Find the maximum. All right, I better move on. Go see Tim or me for help if you're having trouble on that one. I'd be glad to help. We've done things. All right, so how do I take a function like this? 3 over 5x minus 2. How do I find an inverse? Remember that? Yeah. You know what? In fact, you know what I'm going to do? I'm going to skip 15 and do 16. Yeah. So let's do 16. 16 will be even harder, and it's the same thing, and I don't have time for everything. All right, so how do we find an inverse? What's step 1 in finding an inverse? Switch or invert. x and y. And step 2, solve for y. So this will become x, and those guys become y's, huh? So there's step 1, switch x and y. So I switched x and y like that. And now step 2 is I've got to solve for y. Yeah, put this over 1, go diagonal, diagonal. Remember that? 2 equal fractions, cross multiply. So x times minus 9y minus 6, 1 minus 8y plus 6, like that. All right, good. And boom, 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 boom. Minus 9xy minus 6x minus 8y plus 6. Good so far. Everybody good to there? So I'm trying. What am I trying to solve for at this point? Yeah, solving for y, huh? So y is here and y is there.
You want to get them on the same side.
Get them on the same side. That's right. So what do you do when you have y in 2 places? You have to, step 1, get the y, get them on the same side. Same side. So it doesn't matter really which side. So maybe I'll just, whatever, I'll just jump this guy this way and take this guy and go that way. Whatever, either way. So you get minus 9xy plus 8y and plus 6x plus 6. Everybody see what I did there? When things jump to the other side, you know their signs change, huh? Not good to there. So you get them on the, when y's in 2 places, get them on the same side, and then factor out y and divide. Factor out the y and divide. So when y's in 2 places, get them on the same side, factor out the y. See how I factored it out there? And last step, divide. Can you read that? I don't know why that other thing's in the way. Divide by minus 9x plus 8. Boom. I got y alone. So that's some fancy algebra there. Something you have to do a lot of in calculus. Is the y in 2 places kind of thing. Is that good? So what's the answer? Oh, it's obviously A. That's the inverse function. Is that good on that? Are we good there? Now, I want you to watch out because I tried to do it wrong, but it came out perfectly right. I mean, not wrong, but I mean, so it came out the opposite. Because watch out, it's the same as this answer. Can you read that down there? Those serif things in the way. Let me put it over here. This is the same as minus 6x minus 6 over 9x minus 6. That's the same. So watch out on the multiple choice test that you're going to take on Thursday. You might, basically it's just a matter of which way you move the y's. I moved the y's to the left, but you could have put the y's on the right. If you put them on the right and divided, you would have gotten this answer, which kind of looks different than this, but would you know those are the same? How do you know? If you take the top times minus 1 and the bottom times minus 1, boom, 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 you see it gets you the other one. It's not that, it's just that they happen to do the y's on the other side, so it just came out looking that way. Is that right? I don't want you to be fooled on that on the exam. If you get an answer like this and you're looking at one of the options going, I don't know, some of my signs are different. If basically every sign is opposite, that's the same answer. Because that just means they multiply top and bottom by minus 1, changing all the signs on the top and all the signs on the bottom, then that's the same answer really. Grab it, it's equivalent to yours. But if only a couple of the signs are different, but not all the signs, don't grab it. It's all or nothing. All the signs opposite, that's the same answer. Make sense on that? All right, we better move. I thought sure we'd finish this with lots of extra time. I started so early. All right, log, my dreams of time are just that, they're dreams. Log base 1/3 of 81. How do you do that one? Calculator. Just the top goes top, the bottom goes bottom. Super easy. Hit the buttons. I don't know what it is. Negative 4? Yeah, negative 4. B. All right. 18. 18's got a trick. I'm going to move on. Okay, so 18, notice it says f g negative 1. It does not say f of g of negative 1. No little circle in the middle. Right? Everybody see that? What's that matter? There's no, so it's not this, in other words. That's what the circle would mean. So it's not that. Well, then what is it? It's times. It's multiply. See how the f and the g are right next to each other with nothing in the middle? That always means times. So it's not f of g. It's not g plugged into f. It's just times. But I might give you plug in on the test. We had plug in. My practice time is just a general subset. It's not exact verbatim, right? So in the anything in the homework's fair game. In the homework, we did have these kind on graphs. Remember? What section was that? I can't remember now. I don't know. But we had those somewhere. Is it 5? Let's check 5. Hold on. Is it 5-1? Compile. Yeah, it's 5-1. Yeah. C 5.1 graphs. Yeah, so it was right in the beginning. There's problems like number 1 to 5 in 5.1. Make sure you can do all those. There could be a graph with the f of g. Okay, anyway, so this is time. This one is times. So how do you do times? Well, that means it's f of negative 1 times g of negative 1. It's basically negative 1 plugged into both, then times, not 1 plugged into the other. Okay, well, that's still hard. Like, how do you find f of negative 1, for example? How do you look at a picture, a graph, and find f of negative 1? Well, you've got to remember this is x, and what comes out is y. So you've got to look at the f graph. Here's the f graph. And you got to say, hey, f graph, give me the dot that has an x value of negative 1, please. Okay, right there, right there. That's the dot. That's what? Back 1, up 1, isn't it? On the f graph. See that dot? That's the x value negative 1 dot on the f graph. Give me the y value, please. You got it. It's x negative 1, y positive 1. Times. Now do the same thing for g. Look at the g graph. Here's the g graph. And say, g, give me the x value negative 1. Find the dot, x value negative 1. Okay. It's right here. What's that? Back 1, down 2. That's the x, that's the y. Give me the y value, please. Negative 2. So this is 1 times negative 2, negative 2. A. Is that good on that? Question?
Just by looking at it, if you had given us the other question, it would look like it would be 4, yeah?
I don't know.
Because you just go to the negative 2, find the negative 2 on the graph,
Right.
and then track up to the f, right?
Yeah, looks like it'd be 4. Negative 2 up to 4. You're right. Right. All right, I better move on. I want to get... Let's say... All right, f of g of x. So remember, it always means right and left. So it means take all of g and put it right there in the x slot of f, huh? So it'll be 7 over... what is it? 7 over 4 over 3x minus 5. Is that good to there so far? So I put all of g into f. Not good? Now, what do you do? We can't leave it that way. We've got to clean it up. What do we do to clean that up?
Get rid of the fraction.
Yeah, so you multiply by this piece, huh? Everywhere. So 3x, 3x, 3x. Wham, it's gone there. So that's going to be 21x over 4 minus 15x. B. On to number 20. Is that okay there? Get that copied down. So number 20, we look at the y values, don't we? When these table ones, what's happening with the y value? How do you get from 3 to 6 to 12 to 24? Times 2 times 2 times 2. So that means it's exponential. And the exponential form, remember, is b to the x times c. That's the information I gave you back in the homework. The b is the number. This is the b, the 2. How do we find the c? C is number next to x is 0. So look at x is 0, go across. That's your C, 12. So it's 2 to the x times 12. Is that good on that? And you can just plug in points too. Figure it out that way too. All right, so 21, x, let me bring it down here. Oh, I didn't make it very big. Can you see that okay? All right. So, x plus 1/5 squared, x squared plus 6 to the 4th. Okay. So, this part right here, what makes him 0? Plug in negative 1/5, huh? Okay, now this part here, what do you plug in for that one to make that one 0? Nothing. Good. Does everybody see that? Because anything you plug in squared is going to be positive. Add 6, it won't be 0. It's got to be positive. So there's nothing. So negative 1/5 alone. So maybe A, not B because that's positive 1/5. No way. Maybe C. No way on D because they have negative 1/5 and they also have the minus 6. So no way on that. So it's either A or C. Now which one is it? Yeah, what's the power? 2 even, which means it just touches, huh? It's A. Good on that? Everybody good? You know there's no zeros out of this part, right? Nothing can make that 0. All right, so 22, 5 plus 3 ln x is 12. X is saying I want to be alone, so what's my first step? Subtract 5, right? 7. Next step, divide by 3. ln x is 7/3. We good to there so far? Just trying to get x alone. What do I do now to finish getting x alone? Yeah, I got to do the e both sides, right? Because that'll cancel. Because the ln has an understood base e. So remember, powers are opposite of logs, right? Powers are opposite of logs. That'll cancel it out. X will be e to the 7/3. So whichever one that is. Is that not there? Oh, there it is. See. Yeah. Good on that. I'll do number 23 over here on the right side. So 23, e to the x plus 8 is 4. So what do you do to solve 23? That x plus 8, that's like Hitler's climbed into power. What do? What's the opposite of powers? Logs. So I'm going to do ln both sides, huh? Cancel x plus 8 is ln 4. Did everybody make sense of that? So do you see how 22 and 23 are both demonstrating the principle that logs and powers are opposites? So 22 starts with logs. We get rid of the log with a power. And 23 starts with a power. We get rid of the power with a log. So they're opposites of each other. Powers. If you got powers, you get rid of them with a log. If you got logs, you get rid of them with a power. So last step, subtract the 8. So x is ln 4 minus 8. There it is. Now 24, 25, and 3. Let's do 25.
Yeah, I was asking.
Oh, yes, you weren't here.
All right, so how do we do... Notice there's 2 questions, greater than, less than. That's what will be on the real exam. 2 greater than, less than. One of them is a fraction. The other one I skipped, 24, is not a fraction. This is the harder one. So if you have greater than, less than, with a fraction, what are the steps? You can look back. What section is this? This is 4, right? Yeah, 4. This is homework 4. So look back if you have any trouble. We did a whole bunch of them 4. So step 1, get a 0. Step 2, make it 1 fraction. So I'm going to bump this over. 14, x minus 6 minus 12, x minus 1 greater than 0. Step 1, get a 0. Step 2, you got to combine those and make them 1 fraction. How do you make those 1 fraction? Well, you multiply top and bottom by the other guy's denominator. X minus 1 top and bottom here. X minus 6 top and bottom there. Now you can see how that'll make both denominators the same. Now careful when you do that. The minus, this minus sign, I would put him right there. I'll make it plus and negative. I'll put that minus right on the 12. Easy to mess up. 14 goes to these two. 14x minus 14 minus 12x plus 72. I don't know if you tracked with all that. I'm kind of running out of time. So, and now 14x minus 12x is 2x. Minus 14 plus 72 is 58. Over x minus 1, x minus 6. Everybody good to there? Well, we're out of time. I'm going to have to go dot, dot, dot. You got to make a graph, right? Remember, you got to make a graph. The bottom has vertical asymptotes. The top has the zeros. And you got to do all that stuff. Feel free to look back. Let me give you our YouTube clicker thing here. All right. It's open. A for apple, as usual. And we